Welcome to Lasea class. I am your teacher, Jan Lasea. Today I will show you my simple project, Dijkstra Simulator. I teach the topics shortest path and minimum spanning tree algorithms in the subject data structures and algorithms. I use diagrams and pictures with source codes to explain the algorithms, but the diagrams and pictures lack dynamic visualization and results to my students. The program focuses on weighted undirected graphs and represented in adjacency matrix. The Dijkstra Simulator is written in C# programming language. Let us look at the code. The class Dijkstra contains the algorithm for finding the shortest paths between nodes in a graph, which may represent, for example, road networks. It was conceived by computer scientist Edgar W. Dijkstra in 1956 and published 3 years later. Next, the class prim contains the greedy algorithm that finds a minimum spanning tree for a weighted undirected graph. The algorithm was developed in 1930 by Czech mathematician Wojtek Jarnik and later rediscovered and republished by computer scientist Robert C. Prim in 1957 and Edgar W. Dijkstra in 1959. Therefore, it is also sometimes called the Jarnik's algorithm, Prim-Jarnik algorithm, and Prim-Dijkstra algorithm. Next, the class crosscal contains the greedy algorithm that finds a minimum spanning tree for a weighted undirected graph. This algorithm was published by Joseph Crosscal in 1956. Next, the class Form1 is the stage where I instantiated the Dijkstra, Prim, and Crosscal objects. Also, it has methods to draw undirected weighted graph on the monitor screen and animate and highlight the shortest path and display results. Let us compile, run, and test. Let us draw a undirected weighted graph. I click the draw vertex command and then click anywhere on the canvas. So I left click here, I click here, and then click here, and then click here. Next, let us connect the vertices or nodes. I click this command, connect two vertices. I specify the first node or vertex, second node, specify again this node, and connect to this node letter D, and then I will connect node A to C, node C to D, and then finally I will connect node B to vertex or node C. Let us move some nodes or vertex. I click move vertex. Let us specify the weight or distance of the edges. I click the button command set distance. I left click this line segment and then specify a distance or weight, and then click OK. I click the next edge, specify the distance, and then click OK. I specify a weight or distance of this edge, and then click OK. Another edge, specify the distance, and then click OK. Finally, the last edge, specify a weight or a distance, and then click OK. The table on my right, on this right corner, shows the adjacency matrix of this undirected weighted graph. The numbers contains the weight of the edges, as you could see. For example, vertex A to B, the weight or distance is 4, A to B. And then if we go here, the vertex B to A contains that weight or distance of 4. Let us apply the Dijkstra shortest path. I click the algorithms menu, select Dijkstra shortest path. Let us specify the source vertex node A, and we will display the result of the shortest path from node A to all nodes such as node B, node C, node D, except the source node A. So I will specify a value all, and then click OK. The left table here indicates now the result of the Dijkstra shortest path algorithm. We can see source A to B, the distance is 4, the path is AB. We can see here the source A, destination D has a shortest distance 11, the path from node A, node B, C, and D. Let us click again the Dijkstra's shortest path. Let us know what is the shortest path and minimum distance from node D to node A. So I will specify the source node or vertex, letter D. Specify the destination vertex or node, node A. And then click OK. As you could see, the result is displayed here in this table. The source from node D to destination A has a distance, total distance of 11. The path, the shortest path will be, it will start at node D, move to node C, node B, and then finally to the destination node A. The highlighted colored red edges is the shortest path. Let us know what is the shortest path from vertex C to node A. So I click again algorithms, select Dijkstra's shortest path. I will specify the source vertex letter C. I will specify the destination vertex letter A, and then click OK. The shortest distance is 6, and then the shortest path is from the source C goes to node B and node A. The highlighted marked red edges shows now the shortest route or path. Let us implement the minimum spanning tree of this undirected weighted graph. I click algorithms and then select the minimum spanning tree algorithm, Jarnik, and then here it shows now the highlighted red edges that shows now the minimum spanning tree, that all the nodes can be accessed, or it can be visited or travel through this minimum spanning tree. Another definition of a tree, it is a graph that is connected and has no circuits. A minimum spanning tree is a spanning tree that has weights associated with its edges, and the total weight of the tree, the sum of the weights of its edges, is at minimum. Let us also apply Kruskal minimum spanning tree. I click algorithms, minimum spanning tree algorithms, select Kruskal. The results are the same with Prim-Jarnik algorithm. The total minimum distance is 11. This program has also a graph traversal algorithms, breadth first search, and depth first search. Let us choose breadth first. And then the result of the breadth first traversal algorithm is it will visit node A, next node B, C, D. Let us choose depth first search. Next, this program has a sample built-in graph. Let us go to samples menu and then choose binary tree. Let us apply Dijkstra shortest path algorithm. I will specify the source vertex A and what are the shortest path and distance from source A to all nodes B, C, D, E, F, G except node A. So I click OK, and then here in this table contains the result of the shortest path together with the shortest distance from A to the rest of the nodes. Let us know what is the shortest path and distance from node G to node B. So I go to algorithms, Dijkstra shortest path. I will specify the source vertex letter G, the destination vertex letter B. Click OK, and it shows now the total distance and the shortest path or route from node G to node B. That ends our simple project for today. I hope you are inspired in my class. Thank you for watching. God bless us.